everybody. In the last class, we have discussed the asymmetric synthesis and what you mean by chiral pool and the synthesis of the ipsenol. So today we are discussing the classification of the asymmetric synthesis. There are the four different method or four different type of the asymmetric synthesis. So first one is substrate controlled. Substrate controlled means the starting material of the asymmetric synthesis must have a chiral center, and that chiral center will decide the newly generated chiral center in the product. The second variety is the auxiliary controlled asymmetric synthesis. Auxiliary controlled asymmetric synthesis means sometimes the chiral center which is present in the starting material is a very small molecule. That means the starting material is a very small molecule. So that's why there is a possibility of the attack of the nucleophile on the both sides of the chiral center. So in order to avoid that, we are substituting some of the small molecule with a optically active bulky compound, bulky groups, and after the asymmetric synthesis we will remove that bulky group, and that type of the optically active bulky compound which is connected to the starting material only for doing the asymmetric synthesis is the chiral auxiliary compound. Next is the chiral reagent controlled. That means our starting material may not be a optically active compound, but we are using an optically active reagent for the asymmetric synthesis. And the fourth category is the starting material and reagent may not be optically active, but the catalyst which is used for the chemical reaction must be an optically active compound. So these are the different varieties of the asymmetric synthesis. So first one is substrate controlled, so in which starting material is optically active. Second one is the chiral auxiliary controlled. That means starting material may not be an optically active compound and it is a very small molecule. So we are externally connecting an optically active bulky compound to the starting material and do the asymmetric synthesis. After the asymmetric synthesis we will remove this compound, optically active bulky compound, and the product is regenerated. So the next is the chiral reagent control. That means the starting material may not be an optically active compound, but the reagent is optically active. The last one, chiral catalyst control. That means starting material and the reagent may not be an optically active compound, but our catalyst which is used for the chemical reaction is optically active. Now we are detailedly discuss the first category, that is the substrate controlled asymmetric synthesis. So the name itself indicates that our starting material is an optically active compound, and the one of the example is the nucleophilic addition to a chiral carbonyl compound. So here we have to note that the carbonyl group, it is not a chiral functional group because C is doubly bonded to the oxygen and there are two substituents for substituting the valency of the carbonyl group. So, and these two group may be or may not be different, but even then the carbonyl is not an optically active. But here the carbonyl group is attached to a chiral group. That means our starting material is optically active, but our reaction center is in the carbonyl group, and we are adding a nucleophile in the carbonyl site only. So So in this category, the molecule which we have is already have a chiral center, and the carbonyl group is attached to this chiral center, and we are creating an additional chiral center by nucleophilic addition reaction, nucleophilic addition. So that is the difference here. So already that molecule have a configuration, the molecule is optically active, that means that have a configuration R or S. Suppose the configuration of the starting material is S. So after the nucleophilic addition, there is a new chiral center is generated. So that the generated carbon have a configuration that may be R or S. So already we have S optical chiral center in the starting material. That configuration of that chiral center is S, and newly generated chiral center may be S. So our configuration is SS.